Number 7, we've got an improper integral that we're asked to determine whether it converges or diverges. And if it does converge, we find the value to which it's converging. And so remember, the proper way to set this up is to take the limit so I can't go all out to infinity. That's why it's improper. I can go out to some t. So I'll go from 1 to t, and then I'll let the t go to infinity. So I'll try to work this out with that t in there. And so now I'll integrate. This is the limit as t goes to infinity. Well, integrating e to the minus 2x is going to be 1 over minus 2 e to the minus 2x, evaluated at 1 and t. So now I'll take the limit as t goes to infinity, then plug those limits in, and I get minus 1/2 e to the minus 2t. And then I'll subtract. So that's when I plug in the t, and then you subtract and plug in the 1. Well, that's going to be minus 1/2 e to the minus 2. So limit t goes to infinity. So what I've got is this is the formula for what the integral would equal out to any t you want, but I want to see if what this formula turns into. And so maybe it helps in this one if you get rid of that negative exponent by putting it in the bottom. That's what it means to have a negative exponent. You can do it on this other one as well. This other one's going to be plus 1 over 2e squared if you want, but you can leave it alone. It doesn't have a t in it. This is the one I'm concerned with, and I can see that as t gets big, e to the 2t is going to get really big. So this denominator is going to get really big, which takes that fraction to 0. And if that fraction is going to 0, then my answer is going to end up being 1 over 2 to the et. I'm sorry, 1 over 2 e to the 2. Which means the thing converges, and that's what it converges to. Here's another one. This time, it's also improper, just the way it's stated. You can tell it's improper, but the reason it's improper is because if I plug 1 in to the natural log, I'll get a 0 in the denominator. And so this, I've got to take that into account by not going all the way to 1, so I stop at some t again. And I integrate this from t to 2 to find a formula for what that would equal, except then I'll pass the t all the way to 1 once I get that formula and see what happens. And this is coming from above 1 from the right, so it should be a plus there to be technically correct. So there's I'm going to get a formula from that, then see what my formula turns into as I let it get closer and closer to 1, that t get closer and closer to 1. Well, to integrate this is going to require a u substitution. U equal natural log of x. Du is 1 over x dx. Remember, if you have a natural log in your integrand, you're either going to substitute in for it or you're going to use integration by parts. Because I see that 1 over x dx, I know that this substitution is going to work nice. This will be the limit as t goes to 1 from above. So my substitution, I put a u in for the natural log. The 1 over x dx is getting replaced by du. So it'll turn into that. There's nothing left in the integrand to worry about. I do have to change these limits, but I can see all I do is plug them in. When x is 2, my upper limit, you're going to get u equal natural log of 2. So this is in terms of u. The lower limit, when x is t, you're going to get u equal natural log of t. So I have the limit as t goes to 1 from above. Now I can evaluate this. This is just going to be natural log of u evaluated at these limits, natural log t and natural log 2. So that's the limit as t goes to 1. Plug those in. I get natural log of 2. That's a positive number, so I can drop the absolute value. Minus natural log t. Since t is bigger than 1, this is also a positive number. Natural log of t will be. So I could drop the absolute value in both cases, or leave them in there, it doesn't matter. All right, but I do have to figure out now what happens when I let t go to 1. And so I've got a natural log of t. So it does come down to really knowing my natural log graph. It looks like this. And so what this is saying is t is going to 1 from this side. Well, as t goes to 1, we can see that what's inside the natural log will go to 0. So this natural log in here, as t goes to 1, that is going to 0. But now I've got something inside the natural log, this thing, going to 0. So it says I've got another natural log, but what's inside of it is going to 0. Well, if I have something inside the natural log going to 0 from this graph, I can see that the natural log itself is going to go to negative infinity. And so this limit, as t goes to 1, I get something going to 0, therefore this going to infinity. Well, the whole thing's going to be some sort of infinity, which means it diverges.